The problem does not announce itself loudly. It does not arrive as a dramatic revelation or a shocking discovery buried beneath layers of myth. It appears quietly, almost politely, in the surface of stone. A plane that remains flat across several meters, edges that meet at right angles without drift, curved profiles that repeat with the calm confidence of geometry rather than the nervous variation of the human hand. On the granite structures of St. Petersburg, built at the opening of the 19th century, these details persist with an unsettling consistency. They are not decorative flourishes meant to impress. They are technical facts. When measured, they reveal tolerances that should not exist in their time, flatness that resists deviation, parallel faces that do not wander, radii that hold their form without hesitation. The marks left on the stone do not suggest correction or adjustment. They suggest certainty. And this is where the imbalance begins, because these characteristics are not merely impressive by historical standards. They align disturbingly well with machining tolerances that would not become routine until the early decades of the 20th century, when industrial measurement, hardened tooling, and standardized reference systems finally converged. The question does not ask who built them or why. It asks something far simpler and far more dangerous. How did stone shaped in the early 1800s arrive at a level of precision that later generations would struggle to formalize? Precision does not emerge by accident. It is not an aesthetic choice. It is the visible outcome of a measurement system already in place. And yet, standing before these granite surfaces, the reference standard that should explain them is nowhere to be found. Granite is not a forgiving material. It does not behave like limestone or sandstone, which yield gently to chisels and abrade predictably under repeated effort. Granite is crystalline, heterogeneous, internally fractured at scales too small to see and too large to ignore. Each block is a compromise between hardness and brittleness, between resistance and sudden failure. Its mineral grains are locked together in patterns that do not cut cleanly. A tool that bites too deeply will tear rather than slice. A force applied unevenly will propagate microfractures that ruin the surface long before they announce themselves visibly. To work granite at all is to accept waste, irregularity, and correction. To work it precisely is something else entirely. Rough shaping can be achieved with patience, weight, and repetition, but precision shaping requires control over forces that granite actively resists. It requires knowing not only where the tool meets the stone, but where it must not. Granite does not tolerate cumulative error. Each deviation compounds the next. A surface brought close to flat by hand will reveal its imperfections as soon as it is measured. A corner squared by eye will betray itself when aligned against another. Precision granite machining, even today, relies on reference planes, calibrated straightedges, lapping techniques, and constant verification. Without these, the stone wins. This is why granite has always marked the boundary between artisanal ambition and industrial capability. It can be shaped beautifully, but it cannot be shaped carelessly into exactness. And yet, the granite of St. Petersburg presents itself not as a series of heroic struggles against material difficulty, but as a finished product that seems almost indifferent to the challenge it should have posed. Measurements tell the story without emotion. When modern instruments are applied to these surfaces, they do not reveal chaos hidden beneath age. They reveal order that has endured. Planes remain planes across spans long enough to expose any inconsistency. Edges align with a fidelity that refuses explanation through visual approximation alone. Cylindrical and curved elements repeat their geometry not once, but many times, across separate blocks, separated by distance and function, yet united by form. These are not isolated triumphs. They are consistent outcomes. In industrial practice, consistency is everything. It is what separates a fortunate result from a controlled process. Early 20th century machine shops struggled precisely with this problem. Before hardened machine beds, before widespread gauge blocks, before stable reference standards, achieving repeatable precision was an aspiration, not an assumption. The granite in question does not announce itself as superior. It simply matches a level of exactness that later industries would painstakingly define, codify, and defend. And so the question sharpens, if these measurements align so comfortably with standards that did not yet exist, what reference guided them? Precision cannot be verified without comparison. Flatness has no meaning without a plane to judge it against. Parallelism is invisible without alignment. If the stone meets the standard must have been present first. The surviving records offer a strange silence on this point. Architectural drawings show finished forms. Construction accounts list quantities of stone moved, transported, erected. The results are visible everywhere. Heavy, immovable, indisputable. What does not appear are the instruments that would make such results routine rather than miraculous. There are no detailed descriptions of measuring systems capable of enforcing uniformity at this scale. No inventories of precision grinding equipment. No diagrams of reference planes, calibration methods, or verification protocols. The granite arrives in the historical record already resolved, already correct. The process that transformed raw stone into controlled geometry remains unarticulated. In industrial history, tools leave fingerprints. They appear in workshops, in patents, in manuals, in transitional failures. Here, the tools vanish, leaving only outcomes behind. It is not that no tools existed. It is that none appear proportionate to the precision observed. And without proportionate tools, proportionate results become difficult to explain. How does the surface become flat without something flatter to test it against? How does alignment persist across dozens of elements without a shared reference? These questions do not accuse. They observe. They note a gap between what is visible and what is recorded, and they allow that gap to speak. That gap grows louder when repetition enters the frame. A single granite block, however precise, could be attributed to extraordinary effort or singular talent. A craftsman might succeed once through patience, experience, and luck, but St. Petersburg does not offer one block. It offers hundreds, columns that match columns, bases that accept replacements without modification, elements that could be removed and reinstalled without adjustment. This is not the language of chance. It is the language of systems. Repeatability is the signature of a process that does not rely on memory or intuition alone. It implies templates, gauges, standards carried from one operation to the next. It suggests a workflow in which precision is expected, not celebrated. In hand craftsmanship, variation is natural and often embraced. In these granite structures, variation is conspicuously absent. The stone behaves as if it were part of a modular vocabulary, each piece anticipating the dimensions of another. Such interchangeability is not an artistic goal, it is an industrial one. And yet, the industrial context that should surround it remains undefined. What remains, then, is not a conclusion, but a condition. Granite shaped in the early 19th century exhibits precision consistent with systems formalized much later. The material resists explanation through simplification. The measurements align without revealing their origin. The tools that should explain the results do not appear, and repetition transforms what could have been dismissed as anomaly into pattern. This is not an argument about lost civilizations or forgotten technologies. It is a technical observation that refuses to sit quietly within the timelines it is assigned. Precision, once achieved, leaves traces. It leaves methods, standards, transitions. Here, it leaves stone. And stone, unlike paper, does not revise itself to fit expectation. The image is familiar and comforting. The master artisan, sleeves rolled, shaping stone through intuition and experience, achieving greatness through patience alone. It is a powerful myth, reinforced by centuries of romantic storytelling about craft. Handwork is associated with ornament, individuality, and expressive variation. Its strength lies in decoration, in surfaces that carry the signature of the maker, in details that differ subtly from one piece to the next. It thrives where irregularity is acceptable, even celebrated. Standardization, by contrast, has never been its natural domain. When work is guided primarily by eye and touch, variation is inevitable. Each decision responds to the moment, to the resistance felt in the hand, to judgment refined by habit rather than by measurement. This is not a flaw. It is the defining character of handcraft. Precision, when it appears, is local and contextual. It belongs to a single piece, not to a system. The granite of St. Petersburg tells a different story. Its surfaces are notably restrained, ornament is minimal, there is no effort to distract the eye with excess carving or flourish. Instead, attention is drawn almost reluctantly to what should not command attention at all: alignment, symmetry, consistency. The stones do not ask to be admired for their decoration. They assert themselves through exactness. Corners meet without apology, curves repeat without drift. Blocks separated by distance and function share dimensions with an ease that suggests expectation rather than effort. This is not how handcraft normally presents itself. Where the artisan's hand dominates, variation is visible even when skill is immense. Where precision dominates, individuality recedes. These two philosophies do not condemn one another, they simply serve different ends. Handcraft excels where expression matters more than interchangeability. Standardized precision excels where parts must relate to other parts predictably. In the granite structures under discussion, the balance is clear. Expression has been subordinated to alignment. The stones behave less like unique sculptures and more like components within a coherent system. This does not diminish the labor involved. It reframes it. The work appears less concerned with artistic flourish and more with fidelity to an unseen reference. The romantic image of the lone genius artisan struggles to explain outcomes that are repeated, modular, and mutually compatible. It is not that such skill is impossible by hand. It is that the philosophy required to produce it consistently does not match the philosophy traditionally associated with handcraft. The two do not align. History usually preserves its complexities through accumulation. When a new technique emerges, it leaves behind traces of its struggle. Early drawings are rough. Descriptions are incomplete. Experiments fail before they succeed. Apprenticeships form, formalize, and leave records. Tools evolve visibly from crude to refined. This process is noisy. It produces paper, sketches, marginal notes, revisions. It produces evidence of learning. In the case of precise granite machining, one would expect such noise to be abundant. The difficulty of the task alone would demand explanation. And yet, when one looks for this trail, it dissolves into quiet. There are no detailed drawings of specialized granite tools capable of enforcing consistent flatness across large surfaces. There are no manuals describing measurement protocols appropriate to the tolerances observed. There are no institutional records of training programs dedicated to producing such outcomes. Most strikingly, there is no visible period of trial and error. The granite does not display progressive improvement from crude beginnings to refined mastery. It appears in finished form, already resolved. The surfaces do not suggest hesitation, they suggest familiarity. Silence in this context becomes informative. It is not merely the absence of evidence, it is the absence of a learning curve. Complex technologies are rarely born complete. They stumble into existence through iteration. Mistakes accumulate before standards stabilize. Here, the expected disorder is missing. The record jumps from quarrying and placement directly to completion. This gap does not prove intention or concealment. It simply marks an inconsistency between the complexity of the outcome and the simplicity of the surviving explanation. If a technology is difficult enough to require precision systems, why does it leave behind no visible footprint of its own development? One could argue that records were lost, that documents decayed, that time erased what once existed, but loss itself usually leaves uneven remnants. Fragments survive, references echo faintly. Here, the silence is uniform. It spans tools, methods, institutions, and pedagogy. It is as though the knowledge required to achieve the results was not treated as novel or remarkable at the time, as though it required no explanation because it was already understood. That assumption is unsettling not because it implies secrecy, but because it implies normality. A technology that leaves no record of learning suggests a context in which learning was not required. Industrial history provides a useful mirror. When precision measurement became central to manufacturing, it did not arrive quietly. It arrived with debate, resistance, and gradual adoption. The development of reliable straightedges, surface plates, gauge blocks, and machine tools capable of holding tight tolerances was slow and contested. Factories struggled to agree on reference standards. Engineers argued over acceptable error. Entire industries reorganized themselves around the pursuit of repeatability. These efforts unfolded across decades, and they left an unmistakable paper trail. Only after this process did certain levels of precision become routine. Only then could flatness across long spans be assumed rather than verified with effort. Only then could components be manufactured separately and expected to fit together without adjustment. In other words, the standard came first and the products followed. In St. Petersburg's granite, the sequence appears inverted. The products exist, but the standard that would justify them appears later, formalized in a different century under different industrial pressures. This inversion does not require extraordinary explanations. It requires careful attention to sequence. If a measured surface conforms to a standard, that standard must exist conceptually at the time of its creation. It may not be named, it may not be formalized, but it must guide action. Precision without reference is indistinguishable from coincidence, and coincidence does not repeat itself reliably. The paradox lies not in the stone, but in the timeline. Industrial history tells us when humanity learned to demand this level of exactness systematically, the granite suggests that someone, somewhere, was already doing so. Precision at scale is not an individual achievement, it is a social one. It requires shared understanding, not just exceptional talent. When components must align across distance and time, they demand coordination. Training must be consistent. Measurement must be transferable. Standards must be communicated, even if informally. This kind of production implies organization, whether centralized or distributed, explicit or implicit. It implies that accuracy is not an aspiration, but an expectation. Such expectations do not emerge spontaneously. They are cultivated. They reflect values embedded in practice. A society that treats precision as default invests in systems that sustain it. It ensures that knowledge survives individual workers. It designs workflows that anticipate replacement, repair, and continuity. The granite of St. Petersburg behaves as if it were produced within such a framework. The stones relate to one another as though they belong to a shared language of form. This does not identify a civilization or name an institution. It simply asks a structural question: what kind of social environment considers exactness ordinary enough to leave it unexplained? The question is not accusatory. It does not seek to dismantle existing histories. It invites reflection on assumptions. We often imagine past societies as improvisational, constrained by limited tools and informal methods. Yet the physical evidence sometimes suggests otherwise. When materials are treated with such disciplined consistency, they hint at organizational maturity. Precision becomes a cultural norm rather than an exception. That norm, once established, can fade from memory even as its products endure. Nothing in this account denies the established narrative of history. The dates remain, the buildings stand where records say they were built. No alternative explanation is demanded. And yet, the granite remains as well. Its surfaces do not soften to accommodate expectation. They retain their flatness, their alignments still register, their tolerances can still be measured. The discrepancy is quiet but persistent. The stone presents a finished answer to a question that has not been fully asked. Records are incomplete. That is not unusual. What is unusual is how little the absence explains the tools are missing. The methods are unstated. The learning curve is invisible. What remains is the outcome solid and indifferent to interpretation. Granite does not argue, it does not persuade, it simply exists in the state it was left. Perhaps this is enough, not a revelation, but a pause, a recognition that precision, once achieved, does not announce itself with drama. It settles into normality and waits. And when later generations encounter it without the context that produced it, the questions begin to form. Not about who was right or wrong, advanced or primitive, but about sequence, expectation, and memory. Precision does not appear by accident, and it rarely appears without leaving a trace.